Movies are designed to make you whip, thrill, or laugh, but hardly a good source for learning about the laws of nature. Maybe they are even good for unlearning them. The same as they do in traffic schools, where you're presented with a footage with several violations of the law. Today we will try learning some physics from a few brutal violations of its laws in a film. Presenting
If you join the CIA, will you be able to separate your work from your personal life?
Hello?
Get her out of there.
Now.
Let's go. I find this is a weird place to work.
Move and I'll kill you.
You're officially my hero.
Ma'am, close crime scene.
Are you in charge?
Why'd you really come back?
Christian Louboutin.
Let's run the footage and see how many violations you can catch.
In order to beat him, you have to become him. That's not you, is it, Miss Walker?
I'm no longer Miss Walker, remember?
Here's where you're thinking, how much current is too much current? You're thinking, will I get shocked if I don't let go in time?
Here's where you're thinking, where is this going to hurt the most? And why am I sacrificing myself for Henry Wilcox?
Even if I scream out what you want to hear just before I die, you still won't be able to stop him.
Stop him from doing what? What is he going to do to David Dupre?
Whatever he wants. Why are you still holding the cord? Why haven't you put it in the water? Because you're weak, just like David Dupre is weak.
Tell her what he's gonna do to David. I'll kill you. I'll kill you myself.
Well, now the bad guy gets killed, escapes, whatever. How many did you detect? Now let's go over the footage again, this time stopping on each offense to the laws of nature. And stop. The foot into a bucket of water. She must be an expert, this Electrocution.
In order to beat him, you have to become him. That's not you, is it, Miss Walker?
I'm no longer Miss Walker, remember?
What? Did she just pull the cord out of the lamp? Let's look at what kind of forces are involved in this action. Here's how a lamp is built. Notice the cable going into a pipe. Focus now on the electrician part. No way that knot can be pulled through the pipe. So, to pull out that cable, you will have to break it. The most likely gauge for a lamp cable is 14, but according to the AWG table, it will take 119 pounds to break each wire. There are two, remember, totaling 238 pounds. Maybe this scene will make some sense in a movie with this guy, but not with Annie. Let's go on. Is she really rubbing those wires?
Here's where you're thinking, how much current is too much current?
That's the kind of spark you would get if the lamp was still in the circuit, but didn't she remove it?
You're thinking, will I get shocked?
That's what will really happen when there's no lamp to limit the current. Fortunately, in every house there's this, the breaker box. That prevents this. But let's move on.
You're thinking, will I get shocked?
She insists on rubbing those wires.
Here's where you're thinking, where is this going to hurt the most? And why am I sacrificing myself?
Here she goes again.
for Henry Wilkins?
No blinding puff?
Even if I scream out when you
No
want to
break it box in that house?
you still won't be able to stop him.
Stop him from doing what? What is he gonna do to David Dupre?
Whatever he wants. Why are you still holding the cord? Why haven't you put it in the water? Because you're weak.
Can someone remind me what was the bucket for? The bucket's connected to nothing. Wasn't she supposed to be an expert in this? Maybe she missed that class. One of the wires must go to the bucket and the other is for poking. Enough with the bucket. Moving on.
Just like David Dupre is weak.
Tell her. Tell her what he's going to do to
Wires on the floor.
David. I'll kill you. I'll kill you myself.
Really? A little water on the floor and now the breakers go off? Let's watch this again. Once again? You must be kidding. Rubbing copper to copper of those two wires wouldn't do it, but a little water in between is all it took for those breakers to finally do their job. The rest of the footage is just survival with no major violations of the law. However, let's go over this water to electricity thing, which has been abused by the movie industry, turning it into a myth. Electricity and water. Let's bust some myths. Before going into this water thing, we need to bust a simpler myth. Can somebody tell me what's wrong with these images? There are one-point things, like the touch of life and the magic touch. The electric shock is just not one of those things. It is not a one-point thing. You only get an electric shock when an electric current flows through some part of your body. So there must be one point for the current to come in, and at least another one for it to go out. That makes it a two or more point thing. Then why are so many deceived into the one point thing? That's because, though sometimes the second point is straightforward, most shocks happen with the second point being not that obvious. It adds to the confusion that the shock does not always happen. If the sole of your shoes are made of plastic or rubber, these are very good insulators and no current can circulate even if you tuck a live wire at your home. But floors are masonry, tile, wood, or even dust. Aren't these insulators too? They are, if they're dry. And here's where water comes in. Is water a conductor? Nope. Actually, pure water is a good insulator. So good that power companies use it for washing ceramic insulators holding hot, high voltage lines. However, pure water is something that must be manufactured and kept in special containers. The nearest thing in nature to pure water is rain. But as soon as it hits the surface, it starts dissolving most of the stuff it wets. Stuff dissolved in water gets dissociated in positive and negative ions, which are ready to move in the presence of an electric field. Impure water has become a conductor. Is tap water as good a conductor as copper, aluminum, and such? Short answer, no. The magnitude that describes that is the resistivity, which is expressed in ohms per meter. Even the most conductive water is millions of times less than the least conductive metal. In other words, even if you manage to submerge your house in salt water, no breaker would ever trip, except in the movies, of course. Then what's the big deal about water and electricity? Current through water may not trip a breaker or burn a fuse, but it can still give you a good shock and even kill you. Breakers are there to protect your house from short circuit setting it on fire, but cannot prevent electrocution. Water on your skin increases the area of any electric contact, allowing a greater current to flow. That was supposed to be the reason for the bucket in the torture scene. You know, the one she forgot to connect. If you are wet, any electrical contact to a live wire or to a ground will be a better one. A little water on, say, a wooden floor only improves the electrical connection to an insulator, and that would be of absolutely no consequence. But not if it's wet all the way to the body of an appliance, a pipe, or any other metal or ground potential. Being on an electrical fence? Huh. Not a good idea. However, as foolish as this may seem, these folks are not in real danger of getting electrocuted. Ask yourself, how would any current go through them? This is the 1 point thing all over again. Let's rephrase. Where would the current go into their bodies, and where would it come out? It is the power strip that's in danger here. It would eventually be eaten up by electrolysis, never to work again. There would be a pattern of currents in the water, but this will weaken very fast with the distance to the power strip. Just 1 foot away and the current intensity will be 10,000 times smaller, so those folks won't even feel the electricity in the water. But it is not only the movies, which after all is just for entertainment.
And yeah, I try to make sure that I don't see nobody with anything crazy inside the water, like phones or any other kind of cameras or any other electricity devices. And yeah, I try to keep a sharp eye out for those kind of things.
So being a lifeguard isn't just about saving people, it's about keeping a pool safe. And people out there, you should not be bringing your cell phones or your radios or your TVs. That's one of the biggest reasons this happens. Also, pool lights, if they're flickering, that may be a problem. Make sure all electrical equipment is away from the pool. Now, if you're swimming and you feel tingling, or you see somebody in trouble in the pool, or you feel cramps, or you suddenly can't move, you got to get out of the water as fast as possible, Ainsley, because the truth is that water conducts electricity. So how do you get out? You don't go to the ladders because they're electrified. The lifeguard might use a fiberglass hook to help pull you out. You don't go again to the metal, anything near the metal. Get out of the water as fast as you can. If the lifeguard finds that you're not breathing, he's going to put you on a dry surface and give you some rescue breaths.
See what those of us trying to teach physics are up against? Summarizing. The movie footage managed to pack 5 violations in 1 minute and 20 seconds. The pulling the cord out of that lamp, the longest 60 inches ever, the breakers that won't trip with copper but do with water, the unconnected bucket, and the missing blinding puffs. But the news upped the ante. They packed 5 violations in just 50 seconds. Batteries in cell phone, cameras and radios, a drop in the pool can give you cardiac arrest. Flickering 12-volt pool lights may do the same. If you are in shock and can't move, get out of the pool. But don't use ladders, they might be electrified. And wait, they can fish you out with fiberglass hooks. Oh, come on. And this will be all for now. If you liked it and learned something, then subscribe to the channel. So long.